Good morning, judges and other dignitaries who will be reviewing our system. There is something called narrow AI and AGI. Narrow AI are all the LLMs and chatbots that are built today. AGI is something that's in the future. AGI is artificial general intelligence. They possess superior intelligence compared to narrow AI systems. Today, we're building a system that shows hints of AGI. Our focus is to push our models towards AGI. So this is an internally debating LLM system which uses three modules: the generator, critique, and the validator. Let's say you give a prompt to this, ask a question. So the generator generates the prompt, the critique critiques the prompt, the validator validates the prompt. But at each stage we've added two LLMs for improved efficacy and efficiency, and there's a debate between the generator and the critique before passing on to the validator. The validator validates the final answer and gives the output. Now, this is a B2B communication. This is a B2B solution. So more of an academic output or academic output or a research output. So we are focused more on the solution than the application. So we are showing only the back end of everything. So one more important feature that we've added here is AGI memory prototyping. So we have implemented episodic and semantic memory in our model using quadrant and LangChain and RAG. So using this, we are able to generate far more intelligent systems, because semantic memory is something like you ask a question something like who's the prime minister of India, and it gives a fact based question. You ask what is 1 plus 1, or you ask an array based question, it gives you a fact based question. But episodic memory is the memory that an LLM stores right from day 1 till, let's say, day 181, or whichever day you're using. That means it has an advanced context window. Using this, let's we can compare this to a child and a 21-year-old guy. How a child progresses in terms of getting experiences over time, and if you pose a question to a 10-year-old guy and a 21-year-old guy, the scopus of the answers differs significantly. So that is the advanced intelligence we're trying to inculcate here by implementing both episodic and semantic memory. Now we are asking an open-ended question like, should AI be used in medical diagnostics? Now this is kind of a complex and an abstract question. We have also implemented a guardrail system here. Because of time constraints, we're not able to show it. So let's say we are asking a simpler question. So if you ask a much more simpler question, it'll redirect to a simpler LLM and it'll give the answer accordingly. Only if it is a debatable question, it'll move on into the system. Now our log also
Along with your submission, it's compulsory. Every single submission must contain a video, and the portfolio submission will.
I'd also like to add we have another extended feature called Swarm Intelligence.
So make sure all your files
Swarm Intelligence is a cutting edge AI innovation that's at the cutting edge of research. We are trying to implement this swarm intelligence through two styles of communication protocols. One is chain of thought, and the other one is vector column memory using RL, reinforcement learning. Now we'd like to show the working model of it. Think of it as different agents developing their own communication protocol for efficient communication, because English is not the most efficient communication protocol among machines. It could be among humans, but among machines, something closer to machine code is preferable. And this kind of emergence of proto language communication protocols between multiple agents shows advanced intelligence. And that is exactly what we're trying to simulate today. Now here's a working example of that. All of these features are built keeping in mind our vision to push our models closer to artificial general intelligence systems And in the future, sentient AI systems with advanced reasoning, consciousness, and much more powerful memory systems. And we have tried to use efficiency protocols across the domain to reduce the amount of tokens that are being used in the LLM or the API calls so that it won't choke the database. So this is a scalable system. We use guardrails across the domain, across the system. We've also used many efficiency protocols. So this is chain of style thoughts, plan. It shows you the plan. It shows you it shows you the critique. Yes, it looks like a pseudocode in basic layman language. Now we are going one step ahead in terms of our communication protocols. We are using a much more difficult communication protocol. This is called vector column communication using reinforcement learning. So initially it converses with each other using English, and over time using reinforcement learning it develops its own proto language to communicate among each other. Now we'd like to show a demonstration of the same. So first it generates a Q table, a reinforcement learning Q table. So this table uh, assigns scores for the different communication protocols. If the communication protocols are efficient, it gives higher scores. If it's not, it negates the scores, thus pushing the LLM towards more accurate communication protocols. Now we are storing semantic vector, first 5 dimensions. Each word is of 380 dimensions, and as you can see, it's communicating through vector form. For a question like, should AI be used in medical diagnostics? You can see the open router at 0.0, and as it progresses it moves closer towards 1. So because of time constraints we are not able to show it, but when you do come to judge, we'd definitely love to show it to you. This is all our model is about. As you can see, we have the open router now shows